Next, move on to the SSL Record Protocol. What actually the SSL Record Protocol? This SSL Record Protocol which provides two services for secure socket layer connection. First one is confidentiality, second one message integrity. Confidentiality and message integrity. What actually the confidentiality? An handshake protocol defines a shared secured key that is used for conventional encryption of secured socket layer payloads. That is going to be called as confidentiality. Message integrity. The handshake protocol also defines a shared key that is used to form a message authentication code. That is going to be called as message authentication. Let me see about how the SSL record protocol is going to be taken place here. So the record protocol takes an application message and performs the following operations. First, it's going to do the fragmentation. Next, compression of this particular block and adding a MAC, that's nothing but a shared secret key which is used over there, is going to be appended with this, and it's going to have an encryption process. Here we are going to do a symmetric encryption process going to be happen over there. At last, it's going to append an SSL record header for the user verification. Such a way it's going to do this operation. This is going to be called as SSL Record Protocol. I will show an animated SSL protocol, how the operations are going to be taken place for the better understanding purpose. Let me discuss about this. The first one, we are going to take an application data. So an application data which is going to be fragmented. So the fragmentation is nothing but dividing this a big application into a specified block of data. So in general, we are going to divide like this. Number of blocks we are going to divide. An equal number of blocks of data are going to be fragmented, and this fragmented blocks are going to be get compressed. So why we need to compress this? Because to add and MAC data, the block size should not be get enlarged more than the specified block. To overcome this, the data are going to be get compressed first. Then we're going to take the compressed data and we are creating a MAC code. This MAC code is going to be get added along with the particular message. So by adding this MAC code along with this compressed message, the block size is going to be remain the same size as a fragmented block size. So to maintain this, we are going to do the process of compression. So if you're going to see here, the size which is going to be remain same. So to add this MAC data along with this particular compressed data, we are going to maintain this particular block size. Then once we are going to do this addition, adding the MAC code along with the data, then we are going to do the processing of encryption. So encryption process which is going to convert the data into a different form. After the encryption data, we are going to append the SSL record format. So once the record format is going to be get appended, this data is going to be get transmitted. This is a particular record format which is going to be get present in this particular SSL. So the figure which is going to indicate the particular overall operation of this SSL protocol. So here the record protocol takes an application, a message to be get transmitted, fragment the data into a manageable blocks, optionally compress the data, applies the MAC, encrypts, adds an header and transmit the resulting unit in a TCP segment. So the received data and the are decrypted, verified, decomposed, compressed and reassembled before being delivered to the higher levels of users. Such a way this fragmentation is going to be happen over there. So here the first step is going to be fragmentation. Each upper layer message is going to get fragmented into a block of 2 to the power of 14 bytes. That's nothing but 16,384 bytes or less. Next, which is going to do the process of compression, which is an optional one. When we are going to add a MAC data, we need to compress the data, and compression must be lossless and may not increase the content length by more than 1024 bytes. In the SSL version 3 as well as the current version of TSL, there's no compression algorithm is going to get specified, so that the data compression algorithm may be null over there. The next step is nothing but a processing is to be get compute a MAC authentication or message authentication code over the compressed data. For the purpose, what we're going to do, a shared key, a shared secret key is going to get used. The calculation can be done and that is going to be get used over there. Once it's going to be get completed, then the HMAC algorithm may be defined, may be used over there for this MAC. And the difference is that the two paths are concatenated in SSL version 3 and are XORed in the HMAC. That is the difference when we're going to use a MAC and HMAC algorithm for this creation of this particular MAC. The SSL version 3 MAC algorithm is based on the original intranet draft of HMAC, which is used for the calculation. So the final version of HMAC, which is going to be defined in the record format 2104, which uses the XOR operation. Next, the compressed message plus MAC are encrypted using a symmetric encryption, and the encryption may not increase the content length by more than 1024 bytes, so that the total length may not be exceeded 2 to the power of 14 plus 2048. Such a way we are going to maintain this particular thing. So if it's going to be a block cipher, the AES algorithm may be used with 128 bit of keys or 256 bit of keys. Like that we can use an IDEA algorithm or RC2 algorithm, DES algorithm, triple DES algorithm for this particular thing. And meanwhile, when you're going to use a stream cipher, we can use RC440 with a key of 40 byte size, or RC4128 with a key of 128 byte. So for the stream cipher, the compression message plus the MAC are encrypted. For a block encryption, padding may be added after the MAC prior to encryption. So this padding is the form of a number of padding bytes followed by 1 byte indication of the length of padding. So the total amount of padding is a smallest amount such that the total size of the data to be encrypted. So it may be a multiple of cipher block length. Example, a plain text of 58 bytes with a MAC of 20 bytes that is encrypted using a block length of 8 bytes. Example, DES, data encryption standard may be used over there. So with the padding length byte, this yields a total of 79 bytes. So to make the total and integer multiples of 8, 1 byte is going to be get added over there. Such a way it's going to do this particular thing. Then the final step if we're going to see about this, the SSL record protocol processing is to prepare a header consisting of the following fields. The first one is going to be content type. The content type should be an 8-bit. The higher layer protocol used to process the enclosed format is going to be shown over there. The next one, a major version. A major version of 8 bits is going to be mentioned over there, which indicates the major version of SSL in use, or SSL version 3, the value is going to be 3. Such a way the value is going to be mentioned over there. The next one is going to be a minor version. The minor version, which is going to be representing the minor version value in use, that's nothing but an SSL version 3. Actually, it's going to be a 0. Value is going to be a 0, 1. The next one, compressed length. The compressed length is going to be described in 16 bits. So the length in the byte of the plain text fragment, the maximum value is going to be 2 to the power of 14 plus 2048. Or sometimes we can use a compressed fragment with compression is going to be used over there. And such a way these data are going to be get present over there in this particular thing. So the content type that have been defined are chain cipher specific, alert protocol or handshake protocol, and the application data. So the first 3 are the SSL specific protocols, which is going to be a chain cipher specific protocol, alert protocol or handshake protocol. Actually, if you're going to see about this, various applications that might use an SSL, the content of the data created by such applications are going to be OPQ to SSL, which is going to be shown in this particular record format. So this is a record format which is going to be consisting of all the data. The MAC data of 16 or 20 bytes, content type, major version, minor version, and compressed length. And plain text which is going to be present over there, it's an compressed data. Its compression may be optional based on the user end. It's going to be get compressed. So later the MAC data and the plain text both are going to be get encrypted, and header is going to be consisting of all this data. This is going to be called as an SSL record format.